Hello everyone, and welcome to part 2 of the Firebird build. Those of you who are regular viewers know that in 2018 I've switched to a slightly different format of how I release my videos. I'm now uploading one video every week, and in these weekly uploads I show all the progress I've made on any projects in that past week, and I will also make a separate standalone full build video anytime I complete a project. Since this Firebird Drift build was a series that I started in 2017 before moving to this new format, I'm going to continue uploading additional parts of this series until the build is finished, since I don't really want to have just a part 1 video on its own. For those of you who have been watching all the weekly videos, none of the content in this video is anything new. I've just taken segments from the weekly videos, edited them down, and put the clips together for this video. I've uploaded this week's project update video at the exact same time as this video, so if you haven't seen it yet, be sure to check it out. But with that said, here is part 2 of the Firebird build. Here's where I'm at right now as far as the appearance. For wheels, I designed some basic steel wheels, heavily inspired by Cragar's Series 397 Soft 8s, with some PLA 3D printed tires. Now I may change these up at some point, but right now I think these wheels look pretty sick on this car. Easily the most suggested thing you wanted to see on the body was fender flares. At first I wasn't quite sure how I wanted to design them. I figured I didn't want to go with anything too crazy just to keep things clean and simple. Like with most other projects, I began looking for photos of full-scale 3rd gen Firebirds, Camaros, and other similar vehicles with fender flares to get some inspiration. I came across an image of this promotional sales brochure that has a Trans Am with factory fender flares. I think these look pretty nice on the car, so I decided to design mine similarly to how these looked. One difference I made with mine though is I decided to make mine bolt-on flares, just to give them a little more of a custom look. I really like how they look on the car. These are just a test set of flares. I'm going to be reprinting them using different settings and support structure to help get them looking a little bit better. I also made this LS engine topper for the motor. Not sure how scale I'll be able to make the engine bay look, but regardless, I think it looks pretty cool. Moving on to the rear suspension, I needed to mount the trailing arm ends to the chassis. In order to give myself a good place to glue them on, I wanted to first cut and sand away the mounts that are molded into the chassis piece. I started with some sharp Tamiya side cutters and began cutting away the mounts. I next wanted to file down the areas smooth. Before doing this though, I wanted to use a little bit of masking tape to protect some of the surrounding areas. The matte black finish on this chassis looks pretty good, and I'd like to keep as much of it unscathed as possible. The small Tamiya flat file fit perfectly and did a great job of sanding the surface smooth. I needed to do a little bit of further sanding with some coarse grit sandpaper. This will also help the glue to adhere to the chassis a little better. I've now got a nice flat surface on the chassis to glue the trailing arm mounts to. At this point I wanted to attach the wheels and see how everything lined up. It's looking great, although I might have to remove some material from the chassis around where the center of the trailing arm is to allow the car to sit a bit lower. Next I went ahead and glued the trailing arm mounts to the chassis. I did my best to make sure that the axle was positioned correctly. I wanted the axle to be as close to perfectly perpendicular relative to the chassis as possible. I know I could have been a little more precise about lining it up, but I think going off of sight should be good enough for this car. I just used a small dab of super glue to secure the mounts, so if the mounts need to be removed or repositioned, it's no big deal. With the trailing arm mounts in place, I moved on to the springs. I needed to install the spring mounts to the chassis. I started by placing the coil springs on the axle so I could get an idea of where I needed to place the mounts. Fortunately, the surface where I needed to place the mounts is flat, since it's basically the same spot where the springs would be on a full-size car. Of course, I will be making these springs much shorter later on. Right now I'm just using them for alignment. I secure the mounts by placing a dab of shoe goo on the chassis, then I position the mount so that it is aligned with the other mount on the axle. The shoe goo is a little sloppy and doesn't look the best, but it's thick and slow drying, allowing me to easily position the mount where I need it. I repeat the same process on the other side, doing my best to make the alignment as good as possible. Everything seems to be looking good so far. I don't think I'll be using any magnets on this car, at least not in the rear. The magnets act a bit like shock absorbers, but I plan on keeping the suspension low and stiff with just a little bit of travel, so I don't think it will be very crucial on this vehicle. Plus, there is really no good place to mount them on this chassis. In order for them to work optimally, the position and spacing has to be precise. I might mess around with adding some magnets in the future, but for now I'm going to stick with just the springs. Next, I need to install the panhard bar mount to the chassis. This is also being mounted in roughly the same location as where it would be on a full-scale car. This was very easy to mount just behind where the spring mount is on that flat section, but I wanted to cut out a little notch on the mount so that I could sit a little further back. I used a Dremel and a couple of files to create the notch, and then I glued the mount to the chassis. With the mount in place, I then moved on to sizing up the panhard bar. I did some rough measurements from the axle to the chassis mount and cut the panhard bar rod to that length. I began test fitting the panhard bar, grinding down the rod little by little until it was the correct length. Once I got the length correct, I mounted the panhard bar and checked for play and studied the alignment of the rear suspension. Everything looked and felt great. The suspension seems to be aligned well, and the movement of the axle felt smooth, and there isn't a ton of side-to-side play. Although the alignment of the panhard bar isn't perfect, the position of the chassis mount is not quite right, and I'd like to make the panhard bar closer to being perfectly parallel to the axle than what it is right now. I don't think that will have much of a negative impact on the suspension, but we'll see. With everything looking and feeling good, I was ready to complete the assembly of the rear suspension. I installed the springs and mounted the panhard bar. I'm really liking just how scale the rear suspension looks. Despite just placing everything in mostly by sight, the alignment as far as I can tell looks good and the suspension feels great. There's the tiniest bit of play in the axle moving from side to side and just a little bit when twisting the axle. It's not ideal, but I needed a little bit of wiggle room since I was placing everything by sight. I honestly thought there'd be a bit more play than this, so I'm pretty pleased with the result, and I don't think this play will have much of an effect on the driftability of the car. On future builds where I use a custom designed chassis, I'll be able to make the tolerances much tighter and the alignment extremely accurate. What you see here are the smallest components that I had on hand that I knew would be compatible and hopefully will work well in this car. The receiver is a Radiolink R4EH-H. If you've been following me for a while, you know I use these along with the RC4G transmitter on all kinds of different applications. They're cheap, versatile, and have some great functionality. I'll be using a 180 mAh 2-cell LiPo battery, although I also have some 300 mAh batteries I'll probably be using as well if I can get them to fit so I can get a little longer runtime. I think this is like a 2 or 2.5 gram servo. It's quite small and compact, but it's got some good torque. I don't recall any details about this ESC, but it does have a brake and reverse, which is great for this application. And for a motor, I'm using this high torque 130 size DC motor. The first thing I wanted to do was test out all the electronics and bind the transmitter to the receiver. I'm using a different servo, motor, and battery for this, since they have the right connectors for the ESC and receiver I'm using. I've already verified that the servo, battery, and motor I'll be using in the Firebird work, and I'll be changing out the connectors on the battery and servo and wiring the motor later on. With everything binded and working as it should, I moved on to figuring out how exactly I was going to mount all the electronics to the Firebird. As I've mentioned before, I wanted to keep the interior tub intact and make the car look as scale as possible. At a glance, this receiver might seem like a terrible choice due to how big it is in comparison to the car. However, when the outer case is removed, the actual receiver itself is not that large, and I should be able to squeeze it into the Firebird without issue. The length of the antenna is a bit of a nuisance, but on previous builds I've just curled it up so it's out of the way, and I've never had any interference issues, so I should be able to do the same on this car. I spent quite a bit of time placing the components in different areas of the car to see where they would fit best. I figured the best place for the receiver would be in the back, over the rear axle, around where the fuel tank would be on a full-size car, and I would place the battery next to that receiver just behind the rear bumper piece. I'm going to be making some minor modifications to the ESC later on, which will help it to fit better into the car. Obviously, the motor will be placed in the front, in the same general areas where the engine would be on a full-size car, and the servo is going to be placed in the front, but I wasn't quite sure where I wanted to place the ESC. After some brainstorming and deliberation, I decided the two best options would be to squeeze it in between the door and door panel on the side of the car and make a small hole on the side of the interior tub so it would fit, or place it under the dash. I decided that placing it under the dash would be the best spot for it. In order to get it to fit, I will need to cut a large chunk of the firewall out of the body and remove part of the transmission tunnel. This is no issue though, since I was going to do this anyways in order to have ample space to fit the motor and transmission. With the decision made, I began the process of removing those sections. I wanted to remove the dash from the interior tub so I would have better access to the transmission tunnel. The two outer notches came loose no problem, but the lower center section of the dash where the radio and climate controls are is solidly attached to the interior tub. If I forced the dash out, it would probably end up damaging it, so I decided to just work around it. I cut through the plastic using side cutters and a hobby knife, and I used a rotary tool to grind it down further. It's looking like a great spot to keep the ESC, although I will have to watch out for heat. I used a file to give the edge a little more of a smooth, clean look. To help save some space and make the ESC easier to mount, I did some rewiring. I started by removing the on-off switch and replacing it with a small wire. This means that whenever the battery is plugged in, the ESC will be on, but I'd rather have the space than have the switch. I might wire in a much smaller switch sometime in the future. Rather than just using the ESC's JST connector to plug into the motor, I'm just going to wire the motor straight to the ESC. Of course, this will make swapping motors a little more of a hassle, but JST RCY connectors are just too big for this car. I might fit some smaller connectors in the future. After these modifications, I wanted to once again test the ESC to make sure it was still working properly before going any further. And as you can see, everything is working as it should. So I think it was about 3 weeks ago that I first installed the rear suspension onto the Firebird. And in that video I had mentioned that the chassis was going to need to be modified a bit in order to have the rear suspension sit at a much lower ride height. I started by removing the panhard bar so I could flip up the axle, I removed the shocks, and identified where the trailing arms were coming in contact with the chassis. I then began scoring the area with a hobby knife and used some needle nose pliers and side cutters to remove the material. Up near the trailing arm mounts, I used a rotary tool with a small grinding bit to remove material in that area. I did the same thing on the opposite side. I didn't want to remove any more material than what I had to, so I flipped down the axle so I could see where it now sits. I ended up removing material all the way back to the base of the trailing arm mounts. In addition, I also needed to remove some material from around where the trailing arm connects to the axle, since this part was colliding with the chassis. With those modifications made, the rear axle can now sit as low as I want it to. I also wanted to see how it looks with the fender flare on. I think it looks pretty good around this height, maybe just a tad bit higher. I might end up sanding around the wheel arches a bit, and I'll definitely need to add a bit of spacing to the wheels. With enough material removed, I went around with a file to clean up and smooth any rough edges from where I cut. I also filed down the section near the differential housing to give it a bit more clearance. With all that looking good, I reinstalled the springs and the panhard bar. I cut down the springs a little bit, but not too much, since I wanted to wait until I have all the electronics and the interior installed before setting the ride height. With the rear suspension looking good, I went ahead and began working on the front suspension. I briefly talked in last week's video about the front suspension setup I'll be using. Just like the full-scale car, I'm going to be using a modified McPherson strut suspension. This setup is not the simplest design choice, but I'm hoping I can get it to work how I want it. Before installing the K-member, I cut off the motor mount pieces since I won't need them. The K-member piece that I designed fits in the exact same location as the piece that came in the model kit, so mounting will be very easy. I used some sandpaper to sand around where the K-member piece will be located to remove any glue that was left behind, and then I mounted the K-member piece with a little bit of super glue. I designed the K-member piece so that the motor I'm using can sit as low as possible. The angle from the shaft of the motor to the axle is not bad, but I do plan on installing some form of transmission for a little bit of gear reduction and to help make the driveshaft angle even better. Although this setup should look great, I don't think it will allow for a massive amount of steering angle, which will make drifting a lot more difficult. But so far so good. Getting the tolerances just right is a bit of a pain when working with parts this small. I'm noticing that the orientation the part is printed in sometimes has an effect on how well the fitment is, which adds another layer to the equation, but this left side setup feels really good. It's smooth and there's no play. I'm gonna hold off on mounting the strut to the body. That'll probably be one of the last things I do, since once the top of the strut is mounted to the body, I can no longer just easily remove the body like I can right now without having to disconnect the struts. The last sort of tricky thing to design will be the steering linkage. It's going to be small and it's probably going to be fragile, but I'm hoping I can make it just to scale as the suspension. Thank you all for watching, I hope you enjoyed this video, and I'll see you next time.